The purpose of this tutorial is to help you understand histograms and to be able to interpret them better. At this point, I'm assuming that you know how to construct a histogram in Microsoft Excel and that you viewed part 1 of this tutorial series. This is part 2. And what we're going to do today, we're going to continue looking at softball hitting distances, and in particular think about how the histogram may change and what that implies for the people hitting. What I'm going to start you off with was the histogram that we're familiar with. This is the histogram of softball hitting distances for my students. Right now I've got all genders included, and so these hits are comprised of male hitters and female hitters. And of course the x-axis has the intervals in which they're hit, and the y-axis tells us which percent of hits lie in that interval. For instance, approximately almost exactly 10% of students hit between 101 and 125%. And one thing we can tell from this histogram is that hitting distances have somewhat of a uniform distribution, meaning the percent of students who hit between 26 and 50, 51 to 75, and on and on and on, up to 251 to 275 feet, or better say 200 feet, is about the same, meaning about 10% of the students are going to hit between 51 and 75 feet. About 10% of students are going to hit between 151 and 175 feet. Okay. What we want to do now is say, how will this histogram look different if we only include male hitters, and how will it look different if we only include female hitters? These histograms are already constructed for us. What we have here is a histogram of softball hitting distances. Where we only include male hitters. And now look at the histogram. Now the bars tend to get higher towards the right. And let's compare this with the all genders. So this chart below is the histogram for all hitters. This chart above is the histogram for only male hitters. And what we see is that compared to the population as a whole, males tend to hit further. The bars on the right at the higher hitting distances grow taller. The bars at the left, where people only hit, say, 50 feet, grow smaller. And now let's bring in the histogram for females. Down here, this is the histogram where we only include female hitters. And we can see that the bars tend to be higher towards the left at smaller hitting distances, and the bars tend to be much smaller towards the right. And so what this tells us is something we already know, that females on average tend to hit less. And the important point here is to exhibit what you know in the form of a histogram so that you can better interpret histograms. For instance, consider one of our homework problems that students in my AGEC 4213 class will look at. In specific, this is one of the questions they may see. It says, comparing the histogram of male hitting distances to female hitting distances, and then it gives you a number of options describing histograms, and you say which one is right. And the right answer is going to be A. In the male histogram, the bars on the right at higher hitting distances grow taller, and the bars on the left grow smaller. And that's exactly what we see. When we go from the female histogram to the male histogram, the bars on the left shrink, and the bars on the right grow taller. And all the other answers here are wrong. Consider B. In the male histogram, the bars on the right grow smaller, and the bars on the left grow taller. That's not right, because that would be assuming that males hit less far than compared to female. Now consider C and D. C and D may seem odd to you, but they're going to be important in a minute. C says the histogram exhibits greater variability meaning the bars on the ends grow taller and the bars in the middle shrink. This would be describing a situation where when we start off with this female histogram, if this histogram exhibited more variability, then the bars will shrink a little over here but grow taller over here, such that we have bars on across the spectrum where there's hitting distances of some percentage all around. And that's exactly what we find if we change the question to something else. This is another question similar to what's on the homework. This is comparing the histogram of males and females to hitting distances to female hitting distances. So what we're saying, now we want to see what happens when we go from a histogram of female hitting distances to a histogram of hitting distances for all genders. And look at what happens when we go from females to all genders. Well, with females, all the data are clumped towards the rather short hitting distances. When we go to all genders, we have people hitting only 26 feet. We have people hitting 251 feet. What we definitely have when we go from female histogram to all genders is more variability. What we see in C here. C says the histogram exhibits greater variability, meaning the bars on the ends grow taller and the bars in the middle shrink. And so that gives you an idea of how histograms change when the average increases, like when we go from female to male hitting distances. How the histogram changes when the average goes down, say when you go from male histograms to female histograms. And what happens when data exhibits greater variability, when we go from hitting distance just for one gender to hitting distances for all genders. And we can say what happens to histograms when they exhibit less variability. When we go from looking at histograms of all genders to the histogram of just male, the variability declines. Going from here to here, the data start clumping together rather than being distributed throughout. That is the end of this tutorial, and hopefully it helped you understand what it means when histograms clump together, when histograms start to exhibit more variability, scatter apart, and what happens to histograms when the average of a variable changes.